Today we are going to take some notes in our ISN. So on the contents page, you're going to grab your next available page. My next available page is going to be 32. And we're going to call this exponents. And today is the 18th, I'm hoping. I miss you. I'm on the other side of the United States right now. So here we go. Okay, so I'm doing notes on the left side because we're going to have our assignment today is going to be on the right side. So title again, exponents. And it's 11822. All right, so I'm hoping you know some of the things about exponents. I don't expect you to know everything. We did go over a little bit of this, but not a lot. Okay, so first off, we need some words. But we're going to make a big ol' number 4. I want it to take up 4 lines. A big old number 4. And for those of you that like color like I do, I'm going to be using probably 3 colors. After the 4, we're going to make a 2 that's not nearly as big and is mostly up above. It needs to be up higher so that it's clear. If you remember when we did radius squared for circles, this is for squared. Okay, so let's give them some names. This, the big number, is the base. And it is all about that base. Base is the number being multiplied. The number being multiplied. The 2 is the exponent. That is the number of times to multiply. Okay. Give you a second to catch up there. So the big number is the base. That's the number we're going to multiply. The small number is the exponent. That's the number of times we're going to multiply. All right, so let's work this one out. We're going to call this expanded notation. We're going to say 4 times 4. This is number 1. This is number 2. So we multiplied 4, which is the base, twice. Once, twice. So then what we get is standard notation. Four times 4 equals 16. So all three of these are showing the same number. The difference is how it's there. This is the exponent, this is expanded, and this is standard. So I want to take a second and go over why we call this squared. So it would be better if I did this on graph paper, but that's okay. If I had 1 squared, I would have 1 times 1, which is 1. If I had 2 squared, I'd have 2 by 2, which is 4. Does that make sense? It's like we're multiplying it by itself as if it's a square, okay? So let's do a couple more examples. Let's do 2 to the power of 3. So we take that to expanded notation and we say 2 times 2 times 2. So there's 1, 2, 3, because this is 3, okay? And then that equals 2 times 2 is 4, times 2 is 8. Let's do one more example. It's a little bit longer. Well, no, let's keep it at 3. Let's do 8 to the power of 3, or what we call cubed, expanded notation, 8 times 8 times 8, because we've got 3 here. So 1, 2, 3. 8 times 8 is 64. So let's see. I may need to grab a calculator. 64 times 8. 8 times 8 is 32. 6 times 8 is 48. Plus 3 is 51. 512. So 8 cubed is 512. So what we're going to do next, you are going to get a half sheet from my guest teacher. And this is your assignment today. You're going to work on this half sheet and then you're going to glue it in here so that you have it. So what I want you to keep track of on each of these, I've given you 2 examples. 1 squared, the base is 1, the exponent is 2. So the expanded notation, we multiply the 1 by itself twice. 1 times 1 is 1. Okay, another example, 5 squared, or 5 to the power of 2. Base is 5, exponent is 2. 5 times 5 is 25. Gave you 2 examples down here. 1 to the power of 3, or 1 cubed. Base is 1, exponent is 3. 1 times 1 times 1. So 1 times itself 3 times. is 1. And our last example, 5 cubed is base of 5, exponent of 3, 5 times itself 3 times. 5 times 5 is 25. 25 times 5 is 125. All right. So the reason I want you to have this in your book is you'll come back to this in a couple of days. All right, guys, if you have any questions, ask my sub. I'm sure you'll be able to get some help. All right.